Okay, so in this video we're going to talk about set difference. Let's start with our definition. We need two sets. So let S and T be sets. Now the set difference between S and T is the set defined by, and we're going to use the little notation here, S backslash T. You might also find the notation S minus T, but I think this is we're mostly going to be using S backslash T, and it is the set comprised of all of the elements of S such that they are not elements of T. Okay, so in terms of Venn diagrams, what does that mean? We have two sets like this, S and T, and the set difference is this portion right here of S that does not touch T. So let's go over some examples. So for our trivial examples, what are the simplest cases that you could find? So let S be a set. Now we take S, the set difference of S and the empty set. Well, this means that we're taking out no elements because our empty set would be here, and there are no elements in the empty set. So this would give us the original set itself. And if we would take the set difference of S and itself, well, we obtain the empty set because we're eliminating all of the elements in our set S. Because an element cannot be both in and not in a set. That would be crazy. So for a more concrete example, we can have 1, 2, 3, 4. And then the set difference of 1, 2, 3, 4 and 1 and 2. So we're eliminating 1 and 2 from the first set, which means we obtain the set 3 and 4. And this is a good opportunity to show you that the order is very important. The order in which you place the two sets is very important because the set difference of 1 and 2 and 1, 2, 3, 4, we're eliminating 1, 2, 3, and 4. Well, 3 and 4 are not present, so we're not doing anything about them. But we're eliminating 1 and 2, which means that we obtained the empty set. So this shows you that those two sets, that when you reverse the order, it can lead to different sets. Now, very important, let's introduce some notation here. Whenever I'm using an asterisk in a set, so let's say the set of natural numbers, and I put an asterisk here, or I can put the asterisk kind of where the exponent is, what I'm going to mean is that I take the set of natural numbers and I am eliminating 0. Okay, so the same thing goes for if I take the set of integers. This would mean I am going to eliminate 0 from that set. Similarly, if I used the set of integers and I put a plus sign, I'm going to eliminate the negative numbers. So I'm going to keep 0 because 0 is associated to the asterisk. But when I add a plus sign, what I mean is the set of integers, and I'm eliminating -2, -1, and it goes on indefinitely in the left-hand direction. If I use a minus sign, so this way, or I can still put it in the where the exponent is placed, this would be the set of integers, and I'm taking out the positive numbers. So actually, that would be 1, 2, and it goes on indefinitely. If I'm feeling a little bit crazy, well, I can use both. I can put the asterisk and I can put the plus sign, which means I would be left with only the positive numbers. So this is some notation that is going to be frequently used. it's probably in your best interest to remember this. Okay, so remember, the set difference between S and T is the set defined by all of the elements X that are in S such that X is not an element of T.